Hey everyone and welcome back. In the last video we talked about methods in Java. I originally planned to move straight into inheritance, but I want to take a quick detour and explain an important concept that often confuses beginners. And that's primitive versus reference types. Before we dive in, I briefly repeat the basic primitive data types from an earlier video just to make sure we're all on the same page. Also, in this video, I mentioned the terms like interfaces, enums, or arrays. Don't worry, we'll cover each of those in later videos. For now, your main focus should be on classes and objects and understanding the difference in how data is stored and handled in Java. Let's get started. As we know from an earlier video, if you want to rewatch that, the link is in the description below. Java provides us with 8 built-in primitive data types. And these are the most basic forms of data. And they store the actual values directly, but I'll explain this in a second. We have byte, short, integer, long, float, double, char, and boolean. On the right side, you can see an example usage. We have in the first line the declaration of an x variable by assigning the integer 5 to it. Here, x and y are separate values. Changing one does not affect the other because they live independently in memory. You can see in the second line we are assigning x to y and changing y. But changing y doesn't affect x. So if we print them too, we get different values. In a few slides, you'll understand how these two are stored in the memory. But for now, let's look at reference types. Anything in Java that is not a primitive type is a reference type that includes arrays, classes, strings, enums, interfaces, objects, and more. We'll dive deeper into arrays, interfaces, enums, and other types in future videos, but for now let's focus on classes and objects and how they behave when passed around in memory. Let's see what makes reference types different. In the example on the right side, we're creating a person named Alice in the first line. In the second line, we're assigning this person to person 2 and changing its name to Bob in the third line. And then we'll see in the last line that the name of person 1 also changed to Bob. And that's because person 1 and person 2 don't store the actual person objects, they store a reference and pointing to the same object in memory. You can see it in line 2 that we pointed the person 2 to the same object which had the name Alice in memory. Alright, now let's take a moment to understand how memory works in Java, because this is crucial for really understanding the difference between primitive and reference types. Java mainly uses two areas in memory, the stack and the heap. Let's break each of these down. The stack is a small, fast memory used to store method calls, local variables, and references to objects. It operates on the last in, first out principle, which means the last method that was called is the first one to finish and return. Whenever a method is called in your program, Java creates something called a stack frame, and this frame contains the method parameters, any local variables, and the return address, etc. This kind of memory is very fast to access and it has excellent performance because everything is tightly packed. However, it's also limited in size. If your program keeps calling methods without returning, like in deep recursion, the stack can overflow, hence the common error stack overflow error. Now on the other side we have the heap. This is where all objects and reference type data are stored. Whenever you create a new object using the new keyword, it gets stored in the heap. What your variable holds, for example, like the person we just saw, it's not the object itself, but a reference to the object's location in the heap. The heap is much larger and more flexible than the stack. It's managed by the Java virtual machine, and Java takes care of the cleaning automatically by using the garbage collection, and that means you don't have to manually free memory like in C or C++. When there are no more reference pointing to an object, Java will eventually remove it for you. This makes memory management safer and less error prone. Let's make this really concrete by using the examples from before. On the left side, we're using primitive data types and therefore storing the actual values inside the stack. And on the right side, we're dealing with objects. With the new keyword, we're allocating a person object inside the heap. This person object has the name Alice. And on the stack, we have a reference to this object with the name person1. And in the second line, person 1, and in the second line, we're assigning person 1 to person 2. So we're creating a new reference, person 2, but to the same object inside the heap. And if we're now changing the name of this object to Bob, we're also changing the name of person 1 because it's referencing to the same object inside the heap. Is it clear? If you didn't understand this or have any questions, comment down below. Now let's talk about something else called wrapper classes, a concept that often comes up when you're working with collections, generics, or other topics that we're going to look at in future videos. In Java, every primitive data type has a corresponding object-based wrapper class. These wrapper classes wrap a primitive value into an object so it can be treated like any other reference type. For Boolean, we got Boolean, and for int, we got integer, for example. Note the capital case letter at the beginning. These wrapper classes are useful because they allow primitive values to be used as objects, and they also provide built-in methods that can be used in Java features that only work with objects like collections, generics, or streams. Now, I won't go too deep into wrapper classes here. I mainly just want you to be aware that they exist and understand that they behave a bit differently than regular objects. One important difference, wrapper classes like integer are immutable, which means once they are created, their value can't be changed. If you assign a new value, Java simply creates a new object in the background. We'll take a much closer look at wrapper classes, autoboxing, and how they use in real-world code in a later video. So for now, just remember, wrapper classes turn primitives into objects and they give us access to methods, and they allow more flexibility in certain parts of Java. Alright, that's it for today's video. That's a quick summary about primitive versus reference types. Please use primitive for performance and simplicity. Use reference types for complex data like objects, collections, or string. And when a reference doesn't point to any object, its value is null. Remember that. And wrapper classes can be useful in some cases, but we'll look at that in later videos. So if you found this video helpful, please leave a like, give it a thumbs up, subscribe if you haven't already, and turn on notifications so you don't miss what's coming next. Thanks for watching, and I'll see you in the next one.